Hello, in today's video, we are going to be looking at how to calculate the pH of a weak acid. So just as a refresher, in our previous video, we talked about how to calculate the pH of a strong acid. If we have one of our 7 strong acids, it ionizes fully. So whatever your initial concentration of the acid was, that would also be the concentration of the hydrogen ion, and then you can just find the pH from there. When we have a weak acid, it does not ionize 100%. Therefore, we will need to do an ice chart to figure out the amount of hydrogen ion that we will have present at equilibrium. So we take our initial concentration of the weak acid, so that's zero point 0.5. Now we would have none of the acetate or hydrogen ion present initially. Since everything has a coefficient of 1, it's just going to be x or 1x. We're going to be losing the acid and gaining the acetate ion and hydrogen ion. So then at equilibrium, our concentration of the acid would be 0.5 minus x, the acetate ion would be x, and the hydrogen ion would be x. Now we can do our favorite assumption. Since our K is small, we can feel confident knowing that x will be small. Therefore, 0.5 minus x is going to be approximately equal to 0.5. So we can do that modification or that simplification. All right, on the next slide, we are just going to plug these values into our K expression, solve for x, which would be equal to the hydrogen ion. And then once we have that, we can find the pH. All right, so now we would want to write our K expression. So that's going to be the hydrogen ion times the acetate ion over the concentration of the acetic acid. And remember, these are their concentrations at equilibrium. And the value of K is 1.8 times 10 to the negative fifth. We're going to have x squared over 0.5 because we were allowed to do that assumption since K is small, and we explained that on the previous slide. So we are good there. So now we just do 1.8 times 10 to the negative fifth. Multiply that by 0.5. That would give us x squared. So we're going to take the square root of that and get x equal to 3 times 10 to the negative third. If that was our final answer, if we were reporting that, then we would want to have two significant figures, but it's not. So we take that and find the pH, because pH is equal to negative log of the hydrogen concentration, and x was equal to the hydrogen concentration. So it would be negative log of 3 times 10 to the negative third. So we plug that into our calculator and we get 2.52, which makes sense because we have an acid, so obviously we have to be in the acidic range. This is a weak acid, so we should not be ending up with a pH of around 1, so 2.52 makes sense based upon our starting values.